Okay, the second part of your 4-9 notes is talking about inverse functions. It says if f is the name of the function, then you're going to do f to the negative 1. F to the negative 1 is the name of the inverse function. It is read, you don't actually say f to the negative 1. You read this as the inverse of f. It says the relation f is defined on the table below. So these are all your x values. Your input, this would be either your y or your f of x. Either one, they're the same. So it says f of negative 3. So if this is your x, what is the y? So the y, negative 3, the y is 0. It says f of 2, so we find 2 on the x, the y coordinate is negative 3. E is missing. Oh, I think he's supposed to be here. F of 4, 4 on the x corresponds with 5 with the y. All right, when it says f inverse of negative 3, this time they're giving you the y value. So if your y value is negative 3, your x value is 2. Same thing here, f inverse, the inverse of 2. So 2 with your y corresponds with 0 for your x. And if your y value is 4, your x value is 6. It's a funny little table. 13. Definition. The inverse of a function is the relation obtained by switching the order of the coordinates in each ordered pair of the function. That is super important. It's what we're going to do. We are just going to switch the order of the coordinates. So if you have an x, y, then the inverse is y comma x. And it's really that easy. We did 14 together already. So 14 was a line. We started by going down 1 and then did your slope up 1 over 2, up 1 over 2, down 1, back 2. And that gave us these coordinates here. 0, negative 1 is where we started. This is 2, 0. This one's negative 2, negative 2. I think as long as you have 3 or 4 points, you're going to be okay. So all we did then was we switched the order. 0, negative 1 became negative 1, 0. And we plotted that here. 2, 0 became 0, 2, which means over none up 2. Plotted that. Negative 2, negative 2, even if you switch them, it's negative 2, negative 2, right there. So this function and this function are inverses. That's all you got to do. Okay, if we flip over to 15, we did that one as well. We plotted our parabola up 2, came up with these ordered pairs. We switched them. 0, 2 became 2, 0. Negative 1, 3, and 1, 3 became 3, 1, and 3, negative 1. So you can tell there's your inverse. So we'll just do the rest. If you want to just pause this and work on your own, you can. You do what you got to do. Number 16, hopefully you realize, is an upside down parabola that's going to start up 3. Oh shoot, we gotta mark our axes here. There we go. So on number 16, we got to go up 3 and start. 1, 2, 3. This negative means it's an upside down parabola. And then from there, down 2, 3, out 1. All right, I think we're all good at that. Now, I would just recommend coming up with your actual coordinates. So this is 0, 3. These ones are out 1, up 2. So that's 1, 2, and negative 1, 2. And then these ones are out 2, down 1. So 2, negative 1, and negative 2, negative 1. So all I'm going to do is I'm going to switch that order. So that means I've got to plot the point 3, 0. That's my new vertex. 1, 2 becomes 2, 1, and 2, negative 1 from these two. 1, 2, 1, negative 1. And then from here, you can realize that your parabola is opening up this way. So the order would be down 1, over 2, 3. Up 1, up 2, 3. There you go. We're always going to give you the one function to graph first and then graph its inverse. All they did was switch the x and the y in the equation, so all you do is switch the x and the y to graph it. Number 17 is a fishing pole that we've got to go right 3 for. So 1, 2, 3. Fishing pole is just half of a sideways parabola. Up 1 over 1, up 1 over 2, 3. We've got that. Your order pairs here, we start at 3, 0. We go over 1 to 4 and up 1 to 1. And then this one here, 4, 5, 6, 7, 2. So now we just need to flip-a-roo those. 0, 3, 1, 4, and 2, 7. 1, 2, 3. 1, 4 over 1, 4 over 2, up 1, 2, 3, 4, 5, 6, and I'm off the graph a little bit, but that's okay. There we go.